describe the motion in the 2D, or you can say that which is basically that projectile motion, because projectile motion is a two-dimensional version of motion under the influence of the gravity. Let me allow to share my screen with first. Here it is. So we talk about that. We can explain that displacement, general displacement equation of a particle by the equation of this one. We write x equal to x naught v naught xt plus half of ax t square, right? That was the general displacement equation. We will express that way. And this equation is basically not new for you. I said in the previous class, probably used in different way actually, but you should be cope up with that system. And we'll also use this equation for, say, for two-dimensional motion. In the two-dimensional case, we'll write down this equation in the vertical direction. That would be y naught v naught yt plus half of ay t square. So that would be actually that motion in the vertical direction. We'll use these two equations to explain two-dimensional motion. If it's three-dimensional, then you have to add one more dimension, which is the z. You can write that would be z naught plus v naught z t plus half of az t square. Right, so this is actually that three equation, but the same format, right? I will just extend that idea to for 2D and the 3D. That's the same. So any type of motion you can explain by this equation, whether it is moves at a constant velocity or constant acceleration or neither, not any type of equation we can explain from this idea. That's why this is a very beautiful equation, one of my favorite equation. So using that equation we can explain any type of motion, whether it's a 1D, 2D, 3D, or constant velocity, constant acceleration, or neither, not. Everything I can explain from this equation. Say, let's take a case actually. So I'm going to give you an example. Say, for you are standing over here. Say one of your friend actually they're standing at the window. So the distance between you and your friend is, say, that 4 meters. Now, if you throw a ball towards your friend, the ball was caught by your friend, say, 1.5 second later, say t equal to 1.5 second, and it goes upward, and it was caught by your friend by 1.5 second later. Now the question is, what was the velocity it was thrown? So that's mean that initial velocity you can write, so vi, and what was the velocity before it was caught by your friend? So at what velocity did you throw the ball towards your friend? And what was the velocity just before it was caught by your friend? So I want to know these two parameter or two unknown quantity. Now, if you want to use that formula, which is familiar to you, v equal to u plus at, that's not going to work for you over here, because both the quantity, this is your final velocity and this is your initial velocity, both are unknown to you over here, right? So that's why I cannot use this equation over here. But I can use that formula if I write, since I choose, say, this is my vertical direction and this is my horizontal direction, I use that reference axis over here. Then I can write, because this motion is along to the y direction, so that's why I write down the in y format of this equation, y equal to y naught plus v naught y. V naught y actually the initial velocity along to the y direction into t plus half of ay t square, right? So this is my equation. Now, if I choose, so this is my origin, I can write this y naught would be 0. Otherwise, I have to know, if you choose this is your origin, then you have to know the distance between that origin and your distance of the ball. You have to find out that would be in that case y naught. But for my simplicity of the calculation, I just shift the origin from here to here. Fine, then y naught would be basically the 0. V naught y, I am to find out I know the y actually the 4, right? I'm just plugging this value. So y equal to 4, y not equal to the 0, v not y. That's I want to know. T is I know, which is 1.5. And g would be basically minus 9.8, right? Minus 9.8 divided by 2. That's going to the 4.9 into 1.5, sorry, 1.5 square. You understand how I am plugging this value? Remember, I say
Yes, sir.
I said it when you're going to use this equation, y equal to y naught v naught yt plus half of a yt square. You have to use always the acceleration due to the gravity would be always minus 9.8 meter per second square into j head if you express in a vector way actually. Because g is always downward near to the earth's surface, whether you are moving to the upward direction or you are moving to the downward direction, g act on you always towards the downward direction near to the earth's surface. If you are very close to the earth's surface, then g will be always, because that g arises due to the gravitational force which is provided by the earth, right? Gravity, earth is basically attracting everything towards itself, so that's why its direction is the downward. And since the force is downward, so acceleration will be also the downward, so that's why it will be the negative. So that's great. So if I find out, then we'll find out this, we can find out v naught y. V naught y in that case would be 10.01 meter per second. So this is would be basically your initial velocity. So that's when at that velocity it was thrown by you. Now the final velocity they are asking. Now I can use this one. Say I'll write in a different form Vy, which is the final velocity in the y direction, equal to the V naught y, which is the initial velocity, plus Ayt. Right, exactly the same format, but I write in my way. So V naught y, that's I know, which is 10.01 minus 9.8 into 1.5. I just plug in that value. All right. Then I can say this Vy would be, if you do that calculation, you will find out that Vy would be 4.69 meter per second. That would be the velocity just before it was called by your friend. Now, why this minus sign? What is the significance of this minus sign? So we cannot neglect this minus sign over here. There is some significance of this minus sign. This
Sir,
minus sign,
it's
yeah,
downward, that's why.
yeah, this minus sign actually telling us that this when it was caught by your friend, the ball was basically moving to the downward in that direction. It means that when you throw, it's moving to the upward. At that time, your friend was unable to caught that ball. That's why it goes to the upward. It reached its maximum height, then it fall to the downward direction. When it's moving to the downward direction, then it was caught by your friend. That's why your velocity is the negative over here. And in that case, this t actually is a flight of time, total flight of time. The time is taken into total in the flight mode. So that's how actually we can use this equation to explain the what is the actual scenario behind this.
So downward is negative.
A downward is negative, of course. Do you have any confusion on that?
So towards the gravity, it's negative.
Towards the gravity is negative. No, that's not the idea. Idea is that I don't know. Sometimes students say that towards the gravity is negative, towards the opposite direction is the positive. I do not carry that information in that way. I use it this way. This is my reference Cartesian coordinate system, right? Any vector towards upward direction, I will say it would be positive. Any vector towards the downward direction, it would be negative, right?
Yes, sir.
So you said that towards the gravity, yeah, that's fine. Gravity is near to the Earth's surface, is the downward. That's I agree with you. But what about say this is your planet, this is a object, it's a far away from this Earth. Then what would be the direction of this gravitational acceleration on that of that particle, this particle? Will it be downward?
No, it's going to be upward.
It would be towards that direction, right? Because this art or this object actually attracting that one towards itself in that way. then it would be towards basically in this direction, acceleration due to the gravity. So that's why I'm saying that. Look at this one. I'm saying that G would be minus 9.8 near to the Earth's surface. I mentioned that keyword because of that. Excuse me, give me one minute.
Also, sir, in the answer, is it Vy or
I'm sorry,
Uy?
guys. There is some actually construction happening in my flat. So today there will be some noise. All right. Do you understand my point?
Also, also, sir, the answer minus 4.69, is it Vy or Uy?
Vy is the final velocity actually.
Okay, sir.
It doesn't care about that later which one you express, right? So I Vy actually the final velocity actually I express in that way. All right. Then using this equation also we can say that whether a particle moving at a constant velocity, constant acceleration, or neither nor, we can also find out using that one. So basically, say if a particle moves at a constant velocity, what does it mean by the constant velocity? Constant velocity means that the velocity will be not changed with respect to your time, right? And the constant acceleration would be in the case when the acceleration is not changing. Am I right?
Yes, sir.
So then look at this. If I write down that equation, which is x equal to x naught v naught xt plus half of a xt square. This equation is a function of time, right? So it's depend on that t. If you change the t, your x is going to be the change. If you take that second time derivative to find out that velocity, sorry, first time derivative of this position function, dx over dt, that will give me actually the velocity. That's we define that velocity. Then this velocity would be basically x naught is 0, so that means it's a constant, so that's why it's going to be 0. Then v naught x plus it would be axt, because if you take the derivative of t square, that will become the 2t, 2 and this half will be cancelled out. I'll find out that axt. That's mean this function over here, this velocity function is depend on the t. If you change the time, so the velocity is going to be the change. It means that if the particle moves according to this equation, the particle is not moving at a constant velocity. Velocity will be changed with respect to the time. And what about the acceleration? Then acceleration actually dv over dt, which if I take, I'll find out ax only, because va not x in that case constant. And if you take the dt over dt, that will give you the 1. So that's why it will be ax, which is independent of the time. Then I can say that if the particle moves according to this equation, the particle will move at a constant acceleration, because this is a quadratic equation. If you take quadratic equation of the t, if you take the second time derivative, then the t would be the function, or x would be basically the quantity you are taking the derivative, that would be independent of the t. So that's why you can say that because the second time derivative of the position function, we define the acceleration, then we can say that the acceleration would be independent of that time. It means that that quantity is constant. So that's why we can say that if any particle moves according to this equation, particle will move at a constant acceleration. What about, say, if the particle is moving according to this equation, say x naught v naught xt plus t cube, or t square plus one more term over there, t cube, what will happen? Now look at this. If you take in the same way, if I take that velocity, which is dx over dt, this is going to be 0. It would be v naught, or you can say that v naught plus is going to be the 3t square, right? Some other function you will find.
Yes,
And
sir.
acceleration is going to be the dv over dt, which would be basically that 6t. Now If the particle moves along to that, according to this equation, that particle is not moving at a constant acceleration, because that a third order of equation. This is power of this t is basically the third order. So after taking that second time derivative, that function will be also depend on this time function. So that's why if you change the time, your acceleration is going to change. It means that the particle will not move at a constant velocity nor constant acceleration. Right. So I can say
Yes,
the
sir.
particle will move only the constant velocity if the equation format is like that. Say that this one. Then I can say that, because if you take that dx over dt, which we define actually that velocity, that would be x naught would be 0. It would be only that v not x. So that's mean what was initial velocity, that will be also the same, which is independent of the time. In that case, we can say that the particle will move at a constant velocity. That's fine. So suppose if a particle moves at a constant velocity, then what would be that velocity versus time graph? So this is my time, this is my velocity. Then it should be like that one,
Yes, sir. It will be a
right?
parallel line. Yes, sir.
Yeah, so velocity is not changing. Every point the velocity is the same, right? Now, what about say that in that case, what would be the acceleration versus time graph? If it moves at a constant velocity, then what would be the acceleration?
So acceleration is zero, right?
Sir, there won't be
Acceleration is the zero.
acceleration. Yes, sir, because the
Yeah,
velocity is already
yeah.
constant.
Yes, constant means is zero. Zero is also constant. That's right. So that's mean in that case you can say that this will be basically that acceleration over here.
Along
It's a
with
zero.
the
It's not there will be no.
t-axis.
Yeah, along with the t-axis, your time will be increased, but the acceleration is zero value. It will be remain same,
Yes,
right?
sir.
Now, what about say that position versus time graph? So this is the time. So this is my position. What will be that? If a particle moves at a constant velocity, then what would be that position versus time curve?
So there'll be a x equals to y line,
X equal to y.
as in x equals to t line. There's gonna be a line in the middle.
Uh, all right. So can you tell me what is the equation of if a particle moves at a constant velocity, then which equation we should use? Look at this. If a particle moves at a constant velocity, I'm writing my general equation first. V naught xt plus half of ax t square, right? If it is moves at a constant velocity, I know that this acceleration is going to be the zero, right? I'll find out this equation x naught plus v naught xt, right? This will be my equation. Say, for simplicity, I say that it is start from that origin. So that's mean in that case, I can consider this is also x naught is zero, right? Then I'll find out this would be x would be v naught xt. That would be the equation. If a particle moves at a constant velocity, then an equation will be x equal to vt, or you write it s equal to vt equation. Probably you're familiar with this equation. This is the same thing actually, right? We are writing more general way.
Yes, sir.
Now this equation is exactly like y equal to mx, right?
Yes, sir.
So which is actually the straight line equation passing through the origin. You know that one. Say if is this is your x-axis, this is actually your y-axis. You say that in that case, this would be a straight line passing through that origin. Oh God, this would be a straight line
Then,
passing
sir,
through that
when time will
origin.
increase, the value of x will also increase. So that
Yeah,
what
but the ratio would be
will
the
be.
same.
Yes, sir.
right?
V should
Now,
be
what
the
about this
same.
case? What can I can say there? That one. Then what would be this equation? This equation will be also the same. Every time if you take the slope, which is m, and that slope I said in the previous class actually, which is actually you define velocity actually dx over dt, right? We define the
Yes,
velocity
sir. Yes,
dx
sir.
over dt, which is be the slope over here. Every time the slope ratio would be the same, so that's why velocity would be the constant. And this is actually that equation which a particle moves at a constant velocity, then this would be your curve. What about say if that x naught is 0, then in that case what would be that case? Say x equal to x naught v naught xt. Right now what would be that equation or the curve? This is the equation. I want to
Then,
know the curve.
sir, sir, it won't start from this zero origin. It will
Yeah,
start from the value x naught. So it will be in the x-axis from upper any
yeah,
point. Yeah,
right.
there will be a constant value of x naught, and it
Which
will
is
start
actually that
after that
x naught.
x
This
naught.
equation exactly y equal to mx plus c,
Yes, sir. This is the
similar
value
to
of
that one.
c.
This is the value x naught actually the c over here. So that would be this is would be your uh, displacement versus time graph if the particle moves at a constant velocity. All right. What about say if the particle moves at a constant acceleration? If it is moves, I should use different color. If it moves at a constant acceleration, so I will say this is should be my time, and say this is should be my acceleration. Then since it's a it will be remain same, right? Constant acceleration. We can say this would be like that, right? Acceleration is
Yes,
not
sir.
changing with respect to time. It's a constant acceleration curve.
Yes, sir.
What about say that velocity versus time curve? Say this is actually v into t. What is that?
Sir, when time increase, velocity decreases,
Or it could be increases.
or it could be increases. I mean, they will be opposite as v equals to st.
No, 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 no.
Okay.
Look at this here equation. If it is moves at a constant acceleration, then I'll write down this equation x equal to x naught v naught xt plus half of a xt square, right? In that case, my velocity equation actually, uh, which is defined, is a v naught xt plus axt. This is my velocity equation, right?
Yes, sir.
Now I'm going to plot this equation over here. What will be that plot? It's exactly the same. Y equal to, you can say this is
Yes, sir.
C, this is
Yes, sir.
mx,
Mx.
this is will be that one. This is actually your v naught x. And if you take the slope over here, which is actually dv over dt, dv over dt, that's going to give you that acceleration, dv over dt. So that's why this is would be actually that equation. And this is would be your graph. The particle moves at a constant acceleration, velocity versus time graph would be that one. What about displacement versus time graph if the particle
Scroll
moves
up
at a
again.
sorry,
So could you scroll up? I want to see the velocity time graph again.
this one?
This one.
That's is that okay?
So why did it not start from zero? Because
So
of
this is your equation.
not.
Initially, it has some value. So v equal to v naught x plus axt, If you say the velocity is 0, then it will start from there. If we start from the 0, actually. You understand my point?
Yes, sir.
All right, now what about the displacement versus time graph? Displacement versus time graph. If the particle moves at a constant acceleration, if the particle moves at a constant acceleration, so far to
So
the
will it be a curved graph?
yeah, what type of curve?
Upward.
Upward. Yeah, you were close to your answer. Exactly, it would be upward curve. So it would be like, look at this. We'll use this equation again. X equal to x naught v naught xt plus half of axt square. For simplicity, I choose x naught is 0, start from the origin, and we start from the rest also. Then initial velocity is 0. I'll find out this would be a half of a x t square, right? If acceleration is constant, then I can consider this total term half of ax is constant, which would be x would be basically some constant, or you can say that proportional to t square curve, which is we can write it would be y equal to x square curve. Now that means it will be
Parabola.
it will be a parabola like that. That would be the displacement versus time graph if the particle moves at a constant acceleration. You should know this one. We derive from this equation, only this equation. If you understand, then this curve is not going to be a, if you look that curves, we just looking that curve, you can say that whether the particle moves at a constant velocity or constant acceleration or neither not. That's why this equation is a very beautiful equation, one of my favorite equation. What about say if it is free fall, then what could we say that uh, acceleration versus time graph for the free fall case? For the free fall
So
case, say this.
acceleration is increasing, right? Here.
Yes,
Here acceleration is increasing.
acceleration is
It's
increasing in the case of free fall.
No, decreasing.
Is it? If
it's
you drop
increasing. Yes.
something, look at try to understand. If you drop something in the free fall, so uh, is the acceleration of that system is increasing or if it is moving at a constant acceleration? If you say that increasing or decreasing, so that means it's not moving at a constant acceleration, right? If you drop something, and remember, we are neglecting that air friction actually. So if you drop in something, actually, if you drop, then definitely when it's falling, what are the force acting on that object? Or if you throw to the upward direction, anything.
Gravity.
See, sorry?
Gravity. So it's constant acceleration.
Yeah, exactly. So when you drop something, or if you throw something in the upward after releasing from your head, only the gravitational force acting on that object, then definitely it's moving at a constant acceleration. It means that the acceleration will remain same, right? But in that case, that acceleration is negative. So I'm sorry, that's not be the y part. It should be that acceleration. So this is actually that ay, and this is say the time t. Then I can say this is will be my acceleration, which is if I say this is actually that minus 9.8, then that would be the acceleration, which will be the remain same. It's constant, right? What about the velocity versus time graph? Velocity versus time graph. In the case of your dropping something, if you drop something, say you drop something from a height, this the height, you drop something, then what would be the velocity versus time graph? Can you make a guess? Say velocity versus time graph. Hmm?
Sir, when time will increase, velocity will decrease. I mean, these will be disproportional to each other.
Velocity is decreased.
I mean,
Velocity in
When time is increasing,
No,
our velocity will decrease.
no,
so
no. Why velocity is decreased?
constant acceleration. So constant increased velocity, right?
Yes, exactly. Velocity will be increased, but in the negative direction, you can say that. Right. So once you look at this, when you drop it, your initial velocity is zero. Since it is changing its velocity, it's moving at a constant acceleration. It means that definitely that final point velocity will be higher than the initial point. Otherwise, it not accelerated. So whatever the velocity over initial frequency, because we define that acceleration actually the final velocity minus initial velocity divided by time, right? Right. That's the general definition of the velocity. So, and if it moves at a constant acceleration, which is 9.8 minus 9.8, then definitely that point velocity must be higher than its initial point. In the same case, that point velocity would be must be higher than that point. It means that velocity is increasing, but in the negative direction. To make it moves at a constant value, which is 9.8, it has to make that velocity somehow. So the difference between that point and that point is 9.8. It means that basically it is accelerating. That means it's increasing its velocity, but in the negative direction actually. So that's why we can say this should be actually your velocity versus time graph. Velocity is increasing this one with respect to your time, but in the negative direction. Right? Did you get my point?
Sir, could you scroll up a bit again for the acceleration graph?
Is that okay?
Yes, sir.
So is that okay, Asmini, the velocity versus time graph? Remember, when you're dropping something, in that case, basically, the velocity is increasing, but in the negative direction. If you say in that minus sign, actually, yeah, in that case, you can say that the velocity is decreased. If you put in the minus sign in front of that, that value is going to be the decreases, right? You are in a sense of that, you are right. You are right. I'm not saying that is you are wrong, but when you say that the velocity is decreasing, you have to understand. So, which direction is basically? Otherwise, it will make you confusion. What about say if you throw the ball upward direction? What will happen in that case? Hmm? What happened when you throw the ball in the upward direction? When you throw the ball in the upward direction, basically, what happened? Velocity is increasing or decreasing in that case?
Decreasing.
Is decreasing, right? Initially, whatever the velocity is goes to the upward direction, is gradually decreased. That's why it's at the top point, its velocity becomes zero. Then it's again fall to the downward direction, right? So in that case, you can say that whatever the zero velocity initially, after crossing the maximum point, basically it's moving to the downward direction. In that case, you can say the velocity will be increased over here, but in the negative direction. So if I plot that curve, it would be start from there. This would be that plot. It would be the straight line. I'm sorry. Draw a straight line. This will be the case, right? And this point actually that maximum point over here. Come on. Strong. All right, so this is would be at the maximum point where velocity is basically the zero. Starting from when you throw, it has some initial velocity, and with respect to time, the velocity is going to be there decreasing. That's why it reach at the maximum height. At the maximum point, actually the velocity is zero, and after that, basically is increasing, but in the negative direction. That's what the curve actually for freefall motion. All right, let's talk about actually that two-dimensional
So
motion for the, yeah.
we do not need to know the distance time graph for these free fall and upward motion graphs, right?
Yeah, so you can find out what would be that distant curve actually. It will be increased. Like in the case of free fall, what will be the distance?
Okay.
If you drop something, right? In that case, is starting from that. If you choose the origin over there, then its length is increasing. But in the negative direction, it would be that case actually. If you draw,
So will it be zero? The
what would be
end
zero?
date?
Displacement.
No, no, the distance.
Why the distance will be the zero? So that depend actually. That depend. Or I can give you that example. Say, you will find out that idea. Say that another way. What can I do? Say that way. Say you throw a ball with making some angle. Say this is the theta angle, right? This is the trajectory of that uh, particle. Then what would be that displacement versus time graph? What is its displacement? Its displacement basically is that distance is travel in the horizontal direction. This is displacement,
X.
but in the vertical direction, its displacement is basically the zero, right? Because in the vertical direction, it's come to the same height that we define actually the range, which is actually that horizontal displacement. In that case, we define actually the range. If the vertical displacement of the particle is zero, then we'll say that that horizontal displacement would be that range. Otherwise, not. If you think about, if you throw something vertically upward and it goes that direction and come again over here, then the vertical displacement is again zero over here, right?
Yes, sir.
Yeah. And in the case, if you just drop, that would be basically the displacement versus time graph would be in that way. Say this is your displacement, this is your time, this would be that displacement plus time graph. It should be the y. I'm sorry, it's not x. In that case, with respect to time, the displacement is increasing, but in the negative direction, right? Because if you, that depend also why you choose the origin. If you choose, say, you are dropping something from this building, if you choose this is your origin, then this will be negative direction. But if you choose this is your origin, then it would be in the opposite direction actually. So that's how actually you can draw the displacement versus time graph for the free fall. All right, let's talk about the two-dimensional motion, which is basically the projectile motion. Then I will do some problem for this one or two problem if I get the time. All right, so now I'm going to talk about basically that projectile motion, which is the two-dimensional motion under the influence of the gravity. But you don't have to memorize this projectile equation. Although if you memorize those equations, please forget about that thing, which is actually the meaningless. Why I'm saying that meaningless, basically the equation you memorize that works only for the special case. The special case means the ideal situation. If the situation is going to the change, then that equation is not going to work. So that's why we should deal with this thing in a we should deal is this thing in a general way. Fine. So to describe that projectile motion, actually, we have to define a projectile is basically that any body that is given an initial velocity and it's follow a path, right? That path actually we call is a trajectory of that particle. Say, for example, if I thrown a particle, say this is my y-axis, this is my x-axis. I projected that particle with the initial velocity, say that v naught. This is the total velocity, and it makes a angle the theta. Then it will move in a that path, right? Should be symmetric. I'm sorry. That path we say the trajectory. Trajectory. The criteria of this thing, actually, remember, when you projected that particle, you can find out the component of this vector in the two direction. One would be this one, which is initial velocity along to the x direction. Another would be that direction, which is initial velocity to the y direction. I just split that total velocity, total initial velocity, which is V naught. Now I take the component of that one, which is V naught x and the V naught y. V naught x actually initial velocity in the x direction, and V naught y is the initial velocity to the vertical direction. And we can find out that V naught x would be V naught cos theta, right? Because it's create an angle with that x-axis, and V naught y in that case would be V naught cos of 90 degree minus theta. It will automatically give me V naught sine theta, because these axes are perpendicular to each other. So that's why I write down at a time sine theta. All right. Now I know when I throw that particle, after releasing from my hand, the only force acting on that particle is gravitational force. We are neglecting that air friction, remember. So if it is that the gravitational force is only acting on the downward, then I can say there will be no acceleration towards the horizontal direction, right? I can write in that case ax will be 0, because there are no force along to the horizontal direction. The force only in the vertical direction. That's why I can say that ay, which is acceleration due to gravity, will be minus 9.8 meter per second square. This is very important assumption for this motion, or to the projectile motion. That's all. This is the new thing for this projectile motion. Am I right? Do you have any question over here? Is that clear to you?
Yes, sir.
All right. Now let me allow to draw the characteristics of this motion using that idea. Say, I'm going to draw, I should use the dash color. Is the case. Say, this is my y-axis, this is my x-axis. Say, I'm going to draw the trajectory of a particle who is like, it should be symmetric. Say, this is my initial velocity, I thrown with the initial velocity v naught. This create an angle, the theta over here, right? And I also split that vector component, which is v naught x, and this is actually the v naught y. Since I know there are no acceleration along to the horizontal direction, then I can say the particle will move at a constant velocity at the horizontal direction. Am I right? Try to understand my point. When you throw that particle, this particle has a two-dimensional motion. One is towards the x direction, another motion in the towards the y direction. But this particle has a two different characteristics. In the x direction, it will move at a constant velocity, but in the y direction, it will move at a constant acceleration. Because in the vertical direction, you have only the gravitational force, but in the horizontal direction it has no force. So that's why it moves at a constant velocity in the horizontal direction or in the x direction, whereas in the vertical direction it moves at a constant acceleration, and that acceleration is basically ay actually minus 9.8. Now I can say along to the horizontal direction, the particle moves at a constant velocity. It means that the velocity will be not changed throughout its journey. Then I can write this would be that velocity vector. It will be the remain same throughout its journey. Look at this. That's why I try to draw that vector length is same throughout its journey. This is all of v not x. Now say I'm going to draw vy with a different color. Say that I'm going to use the green color or the blue color. I can use. Now the vy, this component, when it's moving to the upward direction, gradually is going to be the decrease, right? It is going to be the decrease, and the top point, the vy must be equal to the 0. This is one more characteristic of this one. After crossing the top point, is velocity is now going to move to the downward direction, and it is going to be increasing that one, but in the opposite direction. This will be the case. This is the vy. I can make an assumption, whatever the velocity it was thrown from here, it will be strike the ground exactly with the same velocity if we neglect the air friction. Using that characteristics, we can predict that one. This is very important. So once you basically, so that's mean using that equation, when it's moving to the upward direction, both the component vx and the vy are positive, but when it moves to the downward direction, velocity x component is positive, but the y component is negative. So for example, if I find a particle is velocity is that in the trajectory, say that phi by plus 2j, I can say the particle is moving to the upward direction because still the y component is positive. If it is moved to the top point, then the total velocity would be only the phi by, because in that case that this 2j would be negative, y component would be negative. If it is crossed that maximum height, then I can say that the velocity would be 5i minus 2j, exactly at the same height. Say this is actually the case where velocity is 5i plus 2j, then at the same height in the opposite point, this is should be actually 5i minus 2j. It means that if your y component is negative, then the particle already crossed its maximum height. So that's why the y vertical component is negative. And we can make some assumption also, say that whatever the time it will take to reach from the bottom to the top, it will take exactly the same time from reach top to the bottom. It's a symmetric. We are talking about the ideal case. So that's why we write. And one more thing, actually, you can say that this particle is the theta is going to be basically decreasing if the height is increasing, right? Because that theta you will define that tan inverse v naught y by v naught x. When it's moving to the upward direction, that means its height is increasing, but the vy is going to be decreasing. If vy is going to be decreasing, then the theta is also going to be basically decreasing, or vice versa. If the height is decreasing, theta will be increased. I'm going to write down this case, actually. Say now what would be the case, say that if we extended that one, what will happen over here? What with the vx? Vx will be remain same, it's not changing because there are no acceleration along to the x direction, so that's why vx will be remain same. What about of this y? Y would be also increasing.
Sir, increasing or decreasing?
In the negative direction it will be increasing.
Yes, sir. Yes, sir.
Right. So that's been, remember, and we say that horizontal distance is the range. You say that one, but I do not say this is range. I say the horizontal displacement. There is a reason why that's so.
So what displacement?
All right. So range should be only the case if your vertical displacement y equal to the 0. Then you can say the range, otherwise not. Say sometime you will find out, say you throw a stone from a height of your building and that strike the ground over here. Now if you use your range formula to find out that distance, that's going to be the wrong. This is not the range. Or the vice versa, if you throw a stone from the ground and it strike the top of the building, and if you say this is actually that range, that is wrong. For the range, the vertical displacement must be the 0. So that's mean this will be the case. Whatever from the height it was thrown, it come back in the same height. That's mean the vertical displacement is the 0. In that case, you can say that this is will be the range, otherwise not. But I can use this horizontal formula, horizontal distance over here. This one is horizontal distance. This one is also horizontal distance. This one is also horizontal distance. That means every horizontal distance is not range. For the range, it is mandatory your vertical displacement would be 0. Now fine. Using that characteristics, I'm going to find out that formula actually. You remember, I'm not going to recommend it you guys to remember that formula. You can find out using that idea actually. So if you just know the equation. So first, I'm going to write this equation of this motion x equal to x naught v naught xt plus half of axt square. Since I know that there is no acceleration along to the horizontal direction, then I'll write this displacement equation along to the horizontal direction would be v naught x into t. This will be the one equation, or sometime we just write down the x equal to v naught x into t if it is start from the origin, if x equal to the 0. And uh, this one, this v naught x, I know which is actually that v naught cos theta. V naught actually the initial velocity it was thrown, making some angle theta, and v naught x actually the component of that velocity along to the x direction, like this. So this is actually your x direction, and this is actually your y direction. You throw the ball with v naught velocity making an angle, then you can take that component of that one. That's why we will use this equation sometime x equal to x naught v naught cos theta into t. Say for simplicity, we define x naught actually that 0. Then this will be v naught cos theta into t, which is actually exactly, if you write if x not equal to the 0, which is exactly the same equation s equal to the vt, which you identify the particle if the particle moves at a constant velocity. All right, that second equation in the vertical direction motion, I'll write y equal to y naught v naught yt plus half of a yt square. I'll choose say that y naught is 0. For simplicity, I choose that starting point is origin. Then v naught y, I'll write v naught sine theta t minus half of g t square, right? These are the basic two equations to solve that projectile motion. Anything I'm going to solve. We'll use one more equation actually, which is also sometimes helpful, or we can use only these two equations. Simply this equation is useful to find out that everything, maximum height or time to reach the maximum height, flight of time, range, blah, 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 everything we are going to find out using this equation. And sometimes we'll use that one also Vy actually V naught sine theta minus gt, which is exactly the same equation, v equal to vy v naught y plus ayt. My v naught y, actually the initial velocity along the y direction, that is actually v naught sine theta minus ay, actually the g into t, right? This will be my equation. So which is I derive from that one, that equation. All right. Now say I want to find out first, say time to take to the maximum height. Say that time to reach maximum height, how much time it will take to reach the maximum height. So I know if it reaches at the maximum height, then what would be its velocity? Vertical component velocity. What would be that?
Zero.
Yes, it would be 0. So then I'll write Vy would be the 0. Then I'll write V naught sine theta minus zt equal to the 0. Or I can write this t up. That's mean time to reach at the maximum point. So that's why I write in the t up. That should be V naught sine theta divided by g. Right? Probably you memorize this equation. I don't have to. I will just plug in the value into that equation. V naught sine theta gt equal to that equation. If you plug in, you can find out the t. This is actually that time to take to the top point, or this would be also your time to reach at the minimum point, that we write t down, t down, t up equal to t down. That should be v naught sine theta divided by g, right? Because we assume that one, whatever the time it will take to from bottom to the top point, from starting from that point to that point, which is t up, it will take exactly the same amount of time to reach from top point to the bottom time. That I write then actually the down, t down. Then we can say that time of flight, which is would be, say that capital T, if I write, it would be 2 t up, right? So that's mean t up plus t down, which would be, and t up equal to the t down. I can write 2 into t up. It would be 2 v naught sine theta divided by g. I'm showing it basically. You guys memorize this equation. But my recommendation is not to memorize this equation. Without doing, I can find out this one. I'm going to show that one, how I'm going to find out this one. And what about that? In that case, the maximum height? Maximum height, we can find out in that case using that formula, say y equal to y naught v naught y t up minus half of g t up square. I say this y naught is 0 for the simplicity. So then v naught y, actually v naught sine theta, t up actually v naught sine theta divided by g minus half of g into t up square is v naught sine square theta divided by g square, right? So that's mean y would be v naught square sine square theta divided by g. Over here, this g will be cancelled out. It will be the half v naught square sine square theta divided by g. I can factor out this one, v naught square sine square theta divided by g. If I factor out, I'll find out 1 minus half. If you do that one, you will find out basically half. 1 minus half will be going to the half. That would be v naught square sine square theta divided by twice g. Then we memorize actually the maximum height equation. But I don't have to memorize this one. If I just plug in that value into that equation, I automatically can find out that maximum height, which is basically the y. This is one method.
The
Another
maximum.
method, yes, yes, go on.
Sure, I was just asking if this is for maximum height.
Yeah, this is actually the maximum height equation. But I'm not encouraging to memorize this equation. Please, guys, do not memorize this equation. It's not going to be the usual case. Sometimes it will be different. So we can use always this equation to find out the maximum height. This equation, if I know the time, or another equation, we can use, say, that one, Vy square would be V naught y square minus 2gy, which is actually V square equal to U square plus 2ax formula. I'm using in the vertical direction. I know if it's reached at the maximum height, V naught y, final velocity is 0. Sorry, Vy. V naught y actually V naught sine theta square, right? Minus 2gy. Then I can find out y would be V naught square sine square theta divided by twice g. It's very simple. I don't have to memorize. I will just plug in the value into that equation. I will find out the y over here. Or if I know the time, then I can use this equation to find out the maximum height using that formula. And the horizontal distance, we can find out the way we should deal. That one, say the horizontal displacement to find out x equal to x naught v naught xt, but we can say the x naught is 0 for simplicity, that calculation, v naught x into t. Now, what is that t? This is very important over here. V naught x, actually, I know that v naught cos theta. Now, what is t? When you talk about that range, it is actually this t, actually the total flight of time, right? Time it take to reach from that point to that point, which is actually double of this t up, because it's take the time to reach at the top, and from the top to the bottom it take the same amount of time. So that's why I can say this t, actually the 2t up, I'll write 2t up, that is going to be v naught cos theta into 2t up is basically v naught sine theta divided by g, and it's become actually v naught square to sine theta cos theta, actually sine of 2 theta divided by g, right? And you say this is actually the range. I'm not going to memorize this equation. To find out the range, I will use this equation only. If I know that v naught x, if I know the time, flight of time, I'll just plug in over here to find out the range or the horizontal displacement. I would say the horizontal displacement, not the range. Range is a very special case, actually. If the situation is different, then this is not going to work for you. Say, for example, uh, you have at the top of a tower, and the height of this tower, say that 80 meter, and you throw that ball horizontally with the speed, say that 30 meter per second. What it will do, it will strike the ground. Now, my question is, what is the time of flight? Time of flight, first question. Second question, what is that horizontal displacement? Or you can say the range. This is not range, actually. I should say, what is x, horizontal displacement? And the number c, what is that final velocity is going to be strike that ground? Now, can you use, if you use that your formula, which is time of flight, which is to, what is that formula? I forget. To v naught sine theta divided by g. That would be the time of flight. Am I right? Let me check that one, because I don't memorize this thing. Hopefully, yes. This is the double of this. This is the formula for your time to total flight of time. You guys memorize. Now, what is theta over here? The theta is
Sir,
basically the velocity create with that horizontal axis when you, yes,
it's 0 here.
is 0 over here for this case, right? So
Yes,
what
sir.
is the value of the sine 0? What is
0.
the value of the sine 0? Is 0. So that's mean this equation telling me it will take 0 second from reach here to here. How? Does it make sense? So that means this is not that appropriate formula over here. This is a very special case. To find out the time, is time actually take to reach from here to here, right? That is actually time of flight. That time of flight, it is also travel this vertical displacement, because it's basically when you throw it, in that case it has only that your horizontal velocity, it has no vertical velocity. Gradually this velocity Vx will be the remain same, but this Vy will be gradually increase in the downward direction, right? It's the case. That's when it's traveling some distance in the vertical direction. Then I can use y equal to y naught v naught yt plus half of a yt square, this equation, to find out the time. Say if I choose, say this is my origin over here, then I can write this y naught is 0, then this y will be minus 80, y naught is 0, v naught y is 0, because initially it was thrown towards the horizontal direction. So if I choose, this is my x direction positive and this is my y direction, then initially the ball was thrown towards the horizontal direction. It means that it has no vertical initial component, right? So that's why this one is going to be the 0, v naught y is also going to be the 0, minus ay is minus 9.8 divided by 2, that will give me 4.9 into t square. Then I can find out the t from there. This t would be, this minus sign will be cancelled out, t will be become 4.04 second. That will be the time. Or this will be also in the flight of time, because in that time that a particle was in flying mood. That's why it's called the flight of time. Now I'm going to find out this displacement, horizontal displacement. This is not a range. If you use the range formula, that should be wrong. I can find out that one using that formula, because I know, so this is question number 1, this is question number 2. I know in the horizontal direction the formula was x naught v naught xt. I'm writing you for again to give you that, remember, or the procedure why I'm writing down this equation. I know in the horizontal direction there will be no acceleration, this will be 0, and if I choose that is the origin, then x naught would be 0. I'll find out x would be v naught xt. You can write down directly that formula if you know this one. Then I'm going to find out that x, this x. Now what is v naught x? V naught x actually over here, v naught, which is actually the 30 meter per second, because at that velocity it was thrown initially, right? This is actually my v naught over here. And this v naught and the v naught x actually the same thing, right? Then I can write 30 into t is I find out, which is 4.04. Then that's why it will give me 121.2 meter. This is will be that horizontal displacement, you can say. Now what about the velocity? At what velocity is going to be the strike over their ground? What will be the velocity over here? Will it be 30 or greater than 30? Can you make a guess? Will it be 30 or greater than 30?
Greater?
This will be greater, definitely it will be greater, right? Because initially it has that 30 meter, which is towards the horizontal direction, meter per second. But I find out also that vertical component, Vy. This is your Vx and this is your Vy. I do not know that value. I have to find out. Then there's a total velocity. Total velocity would be Vx I head plus Vy j head, right? That would be the total velocity over here. I know that Vx actually 30. Now I have to find out the Vy. So Vy I can find out, which would be V naught y plus Ayt. I know the time. V naught y actually there's 0 minus 9.8 into time is 4.04, because 4.04 second later it is going to be strike the ground. I am finding out that velocity just before they strike. because at that velocity is going to be strike the ground, right? Then it will give me basically the minus. Sorry, I'm taking 3 minutes more probably. Hope I can finish within that. 39.59 meter per second. This is that y component. Then I can write down the total velocity. Total velocity would be 30, which is the v naught x I hat minus 39.59 z hat. So this is actually that at that velocity it will be going to be strike the ground. Now, if they ask you what is the magnitude and the direction, I hope you can find out the magnitude and direction of this vector. You know that one, right? If you do that, you will find out that magnitude of this velocity is 49.67, which is greater than 30. That's why I asked you. And the angle would be 307.15 degree or minus 52.84 degree. It's become the minus because when you
Sir, it
strike
will be
that one,
in fourth quadrant, right?
it would be in the fourth quadrant, definitely. This is your
Yes.
resultant velocity. And it create the angle with that x-axis. It's moving to the clockwise direction. So that's why it is 52. This one is 52 over here. 52 point how much? 8. And this one is 307. 307.15 degree. That's how actually you can find out that resultant velocity, magnitude, and the direction. All right, thank you very much. I'm done with you guys for today. This is the end of this
Thank you, sir.
session.